Hello and welcome to the 741 channel. Thank you for stopping by. So my intent with this video was to kind of teach my son a little bit about troubleshooting and electronics and things like that. He's at that age where he's starting to show some interest in that stuff, so just like any parent would, I want to try and encourage those things and let him learn a little bit along the way and maybe try and teach him a few things that I know. Now the one lesson that we both learned on this is that sometimes the solution to a problem is much simpler than it seems. And what we ended up doing is we went through a bunch of needless work on this, when if we had just kind of stopped and thought about it, we would have figured out the problem right from the beginning and realized that the solution was very simple. So what I'll do is I'll show you guys what we did to try and troubleshoot and figure out what was wrong with the RC car. But along the way I'm going to leave a few footnotes in the video and let you guys see if you can figure out what might be going on here before I get to the end of the video and show you the punchline and show you what the actual problem with this thing was. Today we're going to take a look at trying to fix my son's remote control ATV that's up there on the bench behind us. So the first thing we're going to do is a little bit of basic troubleshooting. Now the problem with this is that it's not working at all. So we've done a few things here to just try and eliminate some things that could be wrong with it. So what have we done first?
So there's a red light. There's a red light right there, so
what does that mean?
that means this isn't the problem because it still works.
Okay, good. So we know that this is okay. We've got lights lighting up. The controller seems to be doing what it's supposed to be doing. And we do have good batteries in there. Okay, so just to rule the remote control out as the root of the problem here, I've come over to an amateur radio transceiver that I happen to have here. This is an ICOM IC746 Pro, and I've got this tuned to 49.855 megahertz, which is the frequency that this remote control should be transmitting on. And you'll be able to see and hear that when I activate the controls, the radio will be receiving a signal from the remote control. All of the controls on the remote control seem to be working, generating a signal and a pulse pattern, so that should rule this out as the root of the problem. So we've got some freshly charged rechargeable batteries here that we're going to put in the RC itself. And just to make sure that the batteries are charged, we have checked all of them on the meter here.
So there's one is 1.4. That is 0.4. That's 1.4.
That probe isn't on it. There you go.
That's 1.4. It's 1.4.
Okay, so we know the batteries are good. Let's put them in the RC now and see what's happening. Is it snapped in? There.
There.
Okay. Now, are we sure the batteries are all pointing the right way?
Yeah.
Okay, so what's the next thing we need to do? We need to make sure that this switch is turned on, right?
And it is.
What do you think the problem could be? What should we look at first?
I don't know.
So, we don't really know what's inside of here, but we can make some guesses, right? Yeah. We know that we have the battery pack, and the battery pack has to power something, right? What is the battery pack probably powering?
It's probably powering the circuit board or the motors to make these spin.
Okay.
But it's like somewhere it's loose or it's not connected.
All right, that's a good place to start. So I think that's what we'll do. We'll have to see if we can take this apart and see if there's any wires or connections in there that are broken. So the first thing that we should probably do before we start taking this apart is to get the batteries out of here, just so that...
Yeah, because if it starts running, it could get hot and it'll burn.
Right.
And you have to turn it off.
Right, exactly. Yep, make sure the switch is off. We should have done that before we put the batteries in, actually. So it looks like we've got some screws holding it together. We've got two here, two here. I think there's two in the back someplace, and there should be...
I see one right there.
You see one there. Now there should be two in the front, but it looks like one's already missing. I'm not sure if we tried taking this apart or it just fell out. That may be a clue, because I don't think we've taken this apart. So because there's a screw missing there, it might mean that this crashed into something and something in there broke, and that's why the screw fell out. Anyway, let's pull all the screws out and see if we can take this thing apart without breaking it.
And we got the fourth one out.
Good. Well, let's set this over here in our screw pile. Now hold on. Before you try ripping it apart, there's more screws that need to come out.
There is.
Yep. So try taking that one out next. So one other thing we want to check when we're doing this is if we move to a different part of the unit, the screws might be a little different. So you can see that the screw you just took out is a little bit shorter than the ones that you took out in the middle. So we're going to set those aside in a different pile. So we were kind of thinking this thing should have been kind of loose by now, and it really wasn't. So what we started to figure out is that maybe there's some hidden screws in here, and sure enough, under this sticker is a screw. So I think this one, and there's probably one over here, are really the ones we want to take off to get the back loose. So go ahead and take that one off. Okay, so we got those two off, and yeah, it's a lot looser now. So that's what we needed to do. Let's see. If this is starting to be loose, we can kind of look for where the pivot point is. And I think it's up there in the front where we originally saw those two screws, where the one was missing. So let's take that one that's left out of there, and then we should be able to get this apart. And then just so that it doesn't flop around, I'm going to screw the battery pack down just a little bit so it doesn't keep opening up on us. So now what we should be able to do, I think we've got all the screws off, right? We should be able to just gently pull that apart and have a look inside. Alright, so what do we see inside of here? What does it look like?
A bunch of wires.
A bunch of wires. So we've probably got some wires coming from the battery pack up to this little circuit board, and then over here there's one motor in here that seems like it runs everything. So here's all the main circuit components on this side. You can see all the little IC chips and a little few tiny resistors and capacitors and things.
A U3.
What?
A U4 and a U3 and
yeah,
stuff.
All those U things. And there's even a little antenna right here, and that's what that is. So the first thing we want to look for is obvious signs of broken wires or things that look broken physically. And so let's inspect it for that kind of closely. So nothing actually looks broken on the circuit board. So what I think we're going to do is we're going to put the batteries back in, and we'll try and trace out the voltages and see if we can figure out where the voltage is stopping. Like we talked about, the red and the black wires are the ones that carry the power from the battery up to the circuit board, and it looks like those wires come into this connector right here. So we're going to gently pull that one out of the circuit board, and then we're going to see if we can use our voltage checker to see if there's voltage at this connector. And what that'll tell us is if there's a problem between the battery pack and this connector. So what I'm going to do is I'm going to check these contacts. Can you hold this connector steady for me? So we've made sure the switch on the bottom of the RC is turned on, and I've got the probes inside the end of the connector crimp here, and you may be able to see in the meter that we do have 7 volts. So the power is getting to the circuit board. Let's see if we can troubleshoot from there and see if we can figure anything out. Okay, so my little helper has sort of gotten, I don't want to say bored with the process, but it got a little bit too intense for him at this point, so he's gone off to do something else while I kept kind of digging into this a little bit. So we're taking a look at the circuit board here, and what I think is going on here is this. It looks like these two ICs right here are the motor controllers. This one controls front-back operation, and this one controls right-left operation, as you can see by the nomenclature on the silk screen there. And then this one here looks like it's the radio receiver and sort of brains of the operation. It's probably some sort of microcontroller, but you can see it's close to the antenna. There's a path here from the antenna directly to one of the pins on the IC. This down here looks to be a little bit of a voltage regulator, and it looks like it drops the voltage from 7.5 down to 3 or maybe 3.3 to run this chip. So I've probed some of the voltages in here, and it looks like all of these chips are getting voltage. These appear to be running off of the 7.5 volts, and this one does appear to be getting the 3.3 from the regulator here. So it looks like there are 4 output pins on this microcontroller that are driving signals into, but what appears to be happening is I'm not getting anything out of this microcontroller over to the motor controller ICs. So I've done a little more looking at the circuit and kind of thinking about how things should work. And sort of what I think should happen here is that from the output of the microcontroller, I don't know if you guys can see it or not, but there's 4 traces. 2 go to this motor controller and 2 go to this motor controller through these 2 resistors. So what I think should be happening is that when this receives a signal and decodes it and kind of sends the output through, it should be generating a difference voltage between the 2 lines going to each motor controller. So what I decided to do as a test was take 7.5 volts from over here on the circuit board where I know I have it, and apply it to one of the resistors. And when I do that, you'll be able to see that the motor spins. So I've got one side of this lead over here on 7.5 volts. Now I'm going to take the other lead and I'm going to touch it to each of the resistors, and you should be able to see the motor start to move. I'm going to just do it briefly so the thing doesn't jump off the table. Okay, so what that tells me is that both of these motor controller ICs are okay, and the motors themselves are okay too. It's probably this IC that's shot. So as you saw in the previous clip, the RC car is working just fine now. And the problem was very simple. It really wasn't even a problem at all. Now, in the video, we took a look at this remote control and we checked it and we saw that it worked. Now there's a few telltale signs that I missed that should have clued me in that this was not the remote control for that unit. This actually goes to this other toy that my son has. Now, a little backstory on this is that this RC car is something that my son hasn't used in a few months and had been put away in a box. And he pulled it out and brought it to me because he wanted to play with it. We put some batteries in it, and that's when we figured out that it didn't work. Now, because the remote control has a similar color scheme to the unit itself, it never occurred to me that this wasn't the remote that goes with it. But there are a few telltale signs that should indicate that it really wasn't the right one. The first is that there's two levers on here, but they both go up and down. There isn't a left and right one for steering. And on something like this, there's usually one up and down and one left and right for steering. The other clue is that there's a couple of buttons on here that really don't do anything on this unit. Now, I just thought they were kind of redundant buttons. Never really thought twice about it, but they're really for this thing to kind of make it flip over and do tricks and things like that. The other telltale sign on this is that this thing has a long antenna. And what that means is it broadcasts on 49 megahertz like we saw when we did the test with the shortwave radio. Now, this thing here, I noticed when I took it apart, it had a short little stubby antenna for a much higher frequency. So that should have also clued me in to the fact that this wasn't the right remote. And on top of that, there was some nomenclature on the little circuit board that said 2.4 gigahertz. Another clue that I completely missed or ignored or whatever. So once I kind of realized that, I went back in my son's toy box and I found the right remote control for the unit. And you can see this one says Polaris on it, which matches the stickers on the ATV itself. There's no real antenna on this. There's just a little stubby thing there. And you can also see that this one has a left and right stick and a forward and back stick, which makes more sense from a control standpoint for something like that. And there's no other extra buttons to make it do tricks, because that doesn't do tricks. So the moral of the story here is that sometimes the simplest explanation tends to be the right one, which of course is the scientific precept of Occam's razor, which I kind of alluded to at the beginning of the video. Everybody makes mistakes, especially here on YouTube, and I'm not afraid to show mine. And I thought you guys might enjoy the video and enjoy the process of my son and I going down a rat hole trying to fix a problem that didn't exist. Anyway, if you enjoyed the video, please give it a thumbs up. And if you'd like to leave a comment or subscribe, feel free to do that as well. And if you'd like to support my channel in another way, please consider visiting my Amazon store, which you'll find linked in the description below. Thanks for watching.